So this is a brief features and overview of how to connect a AiM LCU-ONE Lambda controller to a SOLO2 DL device. Currently we have the device connected to a PC via the RayStudio 3 software and a Wi-Fi connection, so there's no actual USB cable plugged into the PC. Just to show that we're connected to the PC, obviously it shows on the screen there PC connection. We can force the device to blink through all of the available screen colors here and show the predictive lap time or RPM shift lights on the side. So there's 5 on each side there. So now we will remove the PC connection since we've already loaded the configuration file on the device. It's a CAN expansion that you can add to the configuration file in RayStudio 3 software. Once you have an LCU-ONE here and you input the serial number, you can actually add it as a CAN expansion, and then it just plugs in directly to this 5-pin connector here. This particular unit is a OBD2 connectivity for ECU connections. So we will go ahead and investigate what happens when we plug in this LCU-ONE. So you can see here this particular screen is showing LCU-ONE data that's been configured to do that. There is no LCU-ONE plugged in yet, so it's just showing blank values for all of the fields here. But you can see the lambda here, the air-fuel ratio. So this is in terms of lambda and air-fuel ratio. This is the sensor temperature in degrees Fahrenheit, and then this is a diagnostic for the controller and sensor circuit itself. So we'll go ahead and plug this in here. So you can see there that it's going through the heat up phase, and it's showing a lambda of 1 or an air fuel ratio of stoichiometric for gasoline here. And then this is the default temperature that's just shown here as it's heating up. So here is the L2 sensor right here. And you'll see in a few seconds, since external voltage has been applied, it's showing that the battery's charging. Now we're seeing live readings here, and since it's in free air, you can see the lambda is maxed out at 1.6 or 23.3 air fuel ratio. So you can see the live temperature of the sensor right there. So 1600 approximately, and then 0 means there's no faults on the diagnostic circuit itself. So I can obviously cool off the sensor if I blow on it there. I'll just put it down for a second. You can see the LCU-ONE, obviously green light indicating that that is connected and enabled here. So what else can we visualize on this particular device? The LCU-ONE does require a 12-volt input. Currently we just have a battery that's not quite fully charged plugged in, so it's showing that it's charging the SOLO2 as well as powering the LCU-ONE. So we'll scroll to the next screen, and you can see we're not currently connected to an ECU, but this is just using the generic CAN OBD2 template to show RPM, throttle position in terms of percent, engine coolant temperature, degrees Fahrenheit, manifold air pressure in terms of PSI. Next page will show fuel level in terms of percentage, intake air temperature in degrees Fahrenheit, the mass airflow through the engine in grams per second, and then the commanded pedal position, so PPS in percent there. Some GPS parameters here on the next page, so your live speed. Currently we're indoors. The altitude is 154 meters above sea level, 4.3 internal volts on the battery, and then 14 satellites is the number of satellites that we're currently communicating with. And this just shows a large value for the speed of the device in the GPS speed from the GPS sensor, the onboard GPS sensor. Going back to the lambda, the temperature of the sensor is stabilized, so we'll try and cool it down here. Just by blowing on the sensor. So you can see there it cooling down. Obviously, the sensor controller will compensate by turning the heater on to control the temperature, and you can see it's right back to where it needs to be for optimum efficiency of Lambda readings. So that was a brief overview of how to connect a AiM LCU-ONE Lambda controller to a SOLO2 DL data logger.